Okay, let's get started with 1-16. So this problem is in lesson 1.1.2, and I'm going to use the book to show you the problem. It's just a better size. So let's look at the problem. Read the math notes box in this lesson and examine the diagram at right. Which angle below is another name for angle ABC? So some of you may be familiar with all of the basic vocabulary and notation for geometry, but if you aren't, or maybe you just need to refresh your memory, this is a great little math note. Let's just read through this together. A point is named using a single capital letter in geometry. So these are all points, D, J, and E. A line, which extends infinitely in two directions, is named using any 2 points on the line. For example, the line at right, you could name this line DE, and see how that has arrows on both sides. I don't know if you can see it, but if you're looking at the e-book, as you should be, you should be able to see the two little arrows there. You could also name it ED or EJ or JE, any two of these letters. The order doesn't matter. And then this has to have arrows on both sides. A line segment is the portion of a line between 2 points called endpoints. In the diagram above, so you could have the line segment between E and J. From here to here, you could name it EJ or JE. So if you're just talking about this length from J to E, then you would name it like this. The point on a polygon where two line segments meet to form a corner is called a vertex. And you'll hear me say vertices for plural of vertex. So you wouldn't say, the plural for vertex is vertices. Okay, so polygons are named by their vertices. Polygons are pretty much any shape that we'll be dealing with this year. So for example, the vertices of triangle ABC are points A, B, and C. And then the angle at vertex B is written angle B. And the measure of angle B is written like this with the italicized M. So when you see this, you read measure of angle B. The length of side BC, if you're talking about the length, you would just write BC. Here that length is 2 centimeters. So angle B, measure of angle B, 80 degrees. BC, the length of BC, is 2 centimeters. A ray is a part of a line that starts at one point and extends infinitely in only one direction. So a ray is named by its endpoint followed by one other point on the ray. In the diagram at right, GF, GH, and GI are all rays. Now it's hard to see on the video, but these all have a little arrow on the right side. It's hard to see even just looking at the book. For lines and segments, the order of the letters in the name don't matter, but when you're naming a ray, the endpoint has to come first. So you couldn't name this FG. You have to start with G because this ray begins at G and goes through F. Okay, the angle is probably the one that causes the most confusion, and formed by two rays joined at their endpoints. The measure of an angle represents the number of degrees of rotation from one ray to the other about their common endpoint, known as the vertex. In this diagram, there are several angles with vertex G. When this happens, the angle is named with 3 letters, and the vertex must be the second letter in the name. So for example, if you saw this picture, if you said angle G, I don't know if you're talking about this angle on top, or if you're talking about this entire angle. So if you have angles that share a vertex, you have to use 3 letters. So the angle that's 10 degrees, this angle here, you could name it angle HGI or angle IGH. Now a lot of times when I'm talking about angles, just to make life easier, I'll put a little number in there and we'll just say angle 2 just to make it easier and faster. But it's important to know this. There could be a question on SAT, and if you don't know how to read the angle correctly, you could get it wrong. And they're usually pretty easy questions. And notice that G is in the middle. The vertex has to be in the middle. You couldn't say, you're not going to start with G. You're going to basically connect the dots. Start with one side of your angle, HGI, or start with this side, IGH. Okay. Looking at 116, which angle is another name for angle ABC? Well, I'm going to draw this in the notebook, and I would like you to draw it also because I want to highlight some things. So quickly sketch out this diagram for 1-16. Pause the video if you need to. And it's asking for another name for angle ABC. So let's look at angle ABC. Angle ABC is this angle right here. So I could name this angle, angle FBG. I could name it angle GBF. Or I can name it angle ABC or CBA. Any of those 4 possibilities would work, but only one of those is given as an option on this problem. So I had said angle FBG when I first started. There's the option that we're given. If you look at these other choices, which I think is a valuable thing to do, if you look at angle, okay, so the answer for this question is you could name it angle FBG, but I want to make sure you understand that why these other choices are wrong. Angle ABE is this angle down here. It's a totally different angle from this angle. Sometimes it helps to like shade in that little piece of the pie right there. There's ABE. Angle GBD. Okay, GBD is this angle up here. Angle EBC. EBC is actually called a straight angle. So that is not the same as angle ABC. Okay, I'd also like you to sketch the diagrams for 1-17. So pause and sketch. You don't have to add the letters for each vertex because this question says, first it's going to give you 2 definitions. If no sides of a triangle have the same length, that triangle is called scalene. That's pronounced like this, scalene. And as you may remember, if the triangle has at least 2 sides that are the same length, that's an isosceles triangle. So you had this last year probably at some point. It says use the markings or description in each diagram to decide if triangle ABC is isosceles or scalene. Assume the diagrams are not drawn to scale. That means that just because things look like they're equal does not mean that they're equal unless you see markings on there indicating that they're equal. So please sketch these quickly in your notebook. This has 2 sides that are equal, so we're going to write 2 sides And in geometry, we say congruent for shapes that are equal. Let's say two sides congruent or two sides equal is isosceles. Now this triangle has 3 different length sides, and you might be looking at this and saying, well, these look like they're equal. Yes, they do look like they're equal in the book, but that's what that statement means. Assume the drawings are not drawn to scale. We cannot make an assumption that these are equal just because they look like they're equal. So here we have no sides congruent. That is a scalene triangle. Part C, it tells us that ABDC is a square. Well, a square has 4 sides that are equal. So we have 2 isosceles triangles. Okay. For 1-18, you do need to draw A, B, C, D, and E. So take a minute, sketch those out quickly. This might be your first time sketching this out, so I thought I would show you an example of how I sketch it out, because a lot of students struggle with this at the beginning of the year. So if it helps, you could literally just turn your paper this way and draw a square, and then divide these 2 sides in half, divide these 2 sides in half. Okay, so you should have all of those sketched out. Add the numbers in there too. And let's look at the beginning of this problem. You will be doing this all year long. So if you don't get it today, it's okay. You will have more opportunities to practice. But this is this is one of the main things that we learn in integrated math too. And it starts off kind of with just simple number patterns. So finding and using a pattern is an important problem-solving skill necessary for your study of mathematics. The patterns in diamond problems are used later in the course to solve other types of algebraic problems. Look for a pattern in the first 3 diamonds below. For the 4th diamond, explain how to find the missing numbers if you know the 2 numbers. Okay, so let's look at this. We are given all the pieces of the puzzle right here. So I can't really remember if you did this in Math 1, but if you didn't, here you go. What do you see here? You've got a 5, you've got a 2, a 10, and a 7. So you're probably thinking to yourself, 5 times 2 is 10. There's something to notice. And then 5 plus 2 is 7. That's it. That's all you have to notice. Let's look at this one. What are we doing to get 6? What are we doing to get 5? Well, you probably have already guessed 2 times 3 is 6, and 2 plus 3 is 5. That's it. That's all there is. Now we've got some negatives thrown in here. Okay, we've got a 4, a -1, a -4, and a -5. Well, it's going to repeat the same pattern. Over here we were multiplying 5 and 2 to get 10, multiplying 2 and 3 to get 6. Is -1 times -4 positive 4? Yes. And then in these first 2 diamonds, 5 plus 2 was 7. 2 plus 3 was 5. Is -1 plus -4 -5? Yes. Okay, so what are we doing to get this number on top? What did we do to get 10? We multiplied 5 and 2. What are we doing to get the number on the bottom? We are adding to get the number on the bottom. So on your very first one, make a little note, because you're going to see this again and again and again and again. This is the product. I'm going to multiply 3 and 5 to get the number on the top. This is the sum. I'm going to add 3 and 5 to get the number on the bottom. That's it. So they're kind of fun because sometimes you're figuring out the missing factors here, and sometimes you're just doing the math. Here we're going to multiply negative 2 times negative 1. That's positive 2. And then we're going to add negative 2 and negative 1 to get negative 3. Okay, here we know that 8 is the product. We know that 6 is the sum. So we're looking for two numbers that we can multiply to get 8, but when we add those two numbers we get 6. Now some of you have already guessed it. What can I multiply to get 8? So most people will guess 2 and 4. Let's try it out. 2 times 4 is 8. Is 2 plus 4 6? We just got it. Not too bad. Okay, we're going to multiply 8 times 1/2. 8 times 1/2 is 8 over 2, which is 4. And then we're going to add 8 plus 1/2, which is 8 1/2. Now, normally I don't write a mixed number in these. We don't have too many that are fractions, but when we do, I usually write the improper fraction. So 2 times 8 is 16. 16 plus 1 is 17. So 17 over 2 when you add them. 8 times 1/2 is 8 over 1 times 1 over 2, which is 8 over 2. That's how I got 4. Okay, what can we multiply to get 12? But when we add it, we get negative 7. So you might be guessing 2 times 6. 2 times 6 is 12. Is 2 times 6 going to give, or is 2 plus 6 going to give you negative 7? Even if you made one of those numbers negative or both of them negative, that's not going to add up to negative 7. And it's okay to guess on these and erase. That's why you're using a pencil. It's okay to make a mistake. It's going to take a little while to get the hang of it. Okay, what else could we multiply to get 12? How about 4 and 3? And if I add 4 and 3, is that going to give me negative 7? That would give me positive 7. I want negative 7. So that means I need both of these to be negative, and that works because negative 4 times negative 3 is positive 12. So take your time getting the hang of this. This is going to be a huge part of your life over the next year. Okay, we are at 17 minutes. Okay, let's go to 1-20. And we're going to pause the video and sketch this Venn diagram. Let's just read the problem first. Copy the Venn diagram on your paper, then show where each person described below should be represented in the diagram. If a portion of the Venn diagram remains empty, describe the qualities a person would need to belong there. Okay, so let's quickly, I'm going to pause the video, sketch this on your paper. Okay, so I've got my Venn diagram ready, and I'm going to look at part A, and we're going to figure out where Carol goes. She says, I rarely study and enjoy braiding my long hair. Okay, so she rarely studies. We're not going to put her in the circle that says studies a lot. So that gets rid of this circle number 1. She enjoys braiding her long hair. Well, she must have long hair. So she's going to fit in circle 2, but she is not going to overlap with circle 1 because she rarely studies. So she's going to be in the part that says just number 2. Carol has long hair, but we're not going to put it here because she doesn't study very much. For Bob says, I never do homework and I have a crew cut. Okay, he never does homework. Does he study a lot? I'm thinking that's a no, so he's not going to go in circle 1. If he has a crew cut, he doesn't have long hair, so he's not going to fit in circle 2, so Bob doesn't fit in either circle. So Bob is on the outside. For part C, Pedro, I love joining after-school study teams to prepare for tests, and I like being bald. Okay, so he goes to study teams to study. So he's studying where he's going to fit in circle 1. Does he have long hair? No. Okay, so he's not going to be any part of circle 2. So he is going to go strictly in circle 1. Part D. Toby says, I really love playing in my heavy metal band, but now that I am enrolled at MIT, I have to study all the time and don't have much time to play. My mom really wishes that I would cut my long, messy hair. Okay, does he study a lot? He studies all the time. So does he fit in circle 1? Yes. Does he have long hair? Yes, he has long, messy hair. Does he fit in circle 2? Yes, he fits in both circle 1 and circle 2. So he's going to go in this overlapping part here. Okay, now we are going to switch gears and we're going to go to checkpoint number 1. Checkpoint number 1 is in the back of your ebook, and if you're looking at the book, it looks like this. You're going to scroll down until you get to number 1 and number 2. We're going to do 1 and 2, and then we're going to skip over to 10 and 11. So remember, the checkpoint is an awesome way to just get better at one particular type of problem. Try a few of these. I picked some that I thought would be quick, easy, kind of fast. Number 1, a rectangle is 3 times as long as it is wide. Let's stop right there. Let's draw a rectangle. So this is checkpoint 1, and we're on number 1. Draw your rectangle. And all we know about this rectangle in the first sentence is it's 3 times as long as it is wide. So I don't know the width, I don't know the length. So I'm going to call the width W. And it says it's 3 times as long as it is wide. Well, if the width is W, then my length is 3 times this. So this is going to be 3W. Now, it does tell us the perimeter is 36. Calculate the length of each side. Well, the perimeter is going to be the sum of all the sides. We know that in a rectangle, opposite sides are equal, so this is going to be W. And this is going to be 3W, and I know W plus W plus 3W plus 3W is 36. The perimeter is 36. So I'm just going to solve for W. I need an equation with one variable so that I can get one solution. So let's go ahead and combine these. That's going to be 2W plus 6W, so that's going to be 8 W's altogether equals 36. Solve for W by dividing both sides by 8. So W is 36 divided by 8 would be 8 goes into 36 4 times with 4 left over. So 4 and 4/8, which reduces to 1/2. And then we could just write 4.5. And I think this was centimeters. So then my width is 4.5, and 3 times 4.5 is my length. So 3 times 4.5 would be, 3 times 4 is 12, 3 times 0.5 is 1.5, so that's going to be 13.5. Okay, let's do number 2. Nancy started the year with $435 in the bank. She's saving $25 a week. Shane started with $875 and is spending $15 a week. when will they both have the same amount of money in the bank? So let's just do a quick chart. Now, if you can do this faster, go right ahead. As long as you show your work, I am good. We have Nancy, we have Shane. Nancy started with $435 in the bank. She's saving $25 a week. So week 0, she's got $435. Week 1, she is up to $435 plus 25. So that's going to be $460. And then Shane started with $875. He is spending $15 a week. So he starts with $875. After 1 week, he's down to $860. So the equation for Nancy, you should be a pro at this by now. If you're not, we have lots of ways to help you get up to speed. But you should recognize that this is a linear equation. This is your starting point. This is your slope. So this is going to be 435 plus 25x. The equation to represent how much he has in the bank. His starting point is 875 minus 15x. When do they have the same amount of money in the bank? You're just going to set these two equal to each other and solve for x. When you have x's on both sides of the equation, you are going to get rid of the smaller one. Negative 15 is smaller than positive 25. Remember, minus is the same as adding a negative. So this is really plus negative 15. So let's get rid of this one. You don't have to, but it makes life easy if you do. So plus 15x on both sides. And that's going to give me 40x here, bring down 435. So 435 plus 40x equals 875. These are gone. And then I've got x on one side. I'm just going to isolate x by subtracting 435 from each side. So 40x equals 440. Let's divide both sides by 40. So x equals 11. So they'll have the same amount of money in the bank at week 11. Okay, now we're going to skip over to number 10 and 11 and review exponentials. It tells you that it's exponential. A powerful computer costs $1,500, but on average it loses 20% of its value each year. How much will it be worth 4 years from now? So remember, an exponential equation is always going to be in the form y equals ab to the x. This is my starting point. This is my multiplier. Now, it tells you computer costs $1,500, so that's our starting point. It loses 20%. If this is confusing, please come see me for tutoring, and let's go over this so that you get it. I'm not going to go super slow this time. I did that in the first video. But I want to keep this video under 35 minutes. So if it loses 20%, that means 80% remains. So my multiplier, let's put 1,500 for our starting point. My multiplier is going to be 0.80. Now, if that is confusing, why am I putting 0.8? One way to remember it is if it's decreasing, this is going to be 1 minus your percent decrease. If it's increasing, it's going to be 1 plus whatever your percent decrease is. And the percent would be written as a decimal. So if I do 1 minus 20%, 1 minus 20%, would be 1 minus 20% is 20 out of 100, which is 0.20. And 1 minus 0.20, that's where I got the 0.80 from. Now it still might be confusing, and we can go through this a different way. We can look at, like, you know, one number at a time. But I want you to understand this and not just be memorizing things, because when you just memorize things or you don't really understand it, you're not going to remember it on a test, and that's going to hurt your grade. Okay, so we are trying to figure out how much this computer is going to be worth in 4 years. So I'm just going to substitute 4 for X. Now, on your ebook, you have a calculator. Get used to using that now. If you don't have something at home that you can use this, because I can't flip it back and forth between paper and pencil to the computer screen. So I'd like to show you what I'm doing. Whoops. Okay, so 1,500 times 0.8 to the fourth is $614. And what was that? 40 cents. So that computer, after 4 years, if it's decreasing 20% each year, after 4 years, it's only worth $614.40. Are you getting the hang of these? Number 11, dinner at your grandfather's favorite restaurant costs $25.25. And it's been increasing steadily at a 4% per year rate. How much did it cost 35 years ago when he was courting your grandmother? Okay, let's start off with our exponential equation. Our starting point is $25.25. That's what it costs right now. It's increasing. Well, if it's increasing, it's going to be 1 plus the percent. Oh, I put decrease right there. I should say increase. 1 plus the percent increase. Okay, so my starting point, $25.25. This is going to be 1 plus 4%. 4% as a decimal, 4 out of 100 is the fraction. As a decimal, that's 0.04. So this is going to be 1.04. It's increasing, it's going to be above 1. If it's decreasing, it's going to be below 1. Now, how much did it cost 35 years ago? I'm going backwards. So instead of saying positive 35, we're going to say negative 35. So let's see what the cost of this meal was 35 years ago. And you could do something like this with the calculator on the ebook with Desmos. $6, why don't we round that off to $6.40? So in 35 years, it's gone from $6.40 to $25.25. Okay, that's it for tonight's homework.